G'day. In this third video about creating a network probe that's going to run on an Esp32 microcontroller, I put together the code that's used for logging the results as well as the code for retrieving the history of those results. Actually, I'm not sure if anyone will watch this unless someone really wants to see how I put together the microcontroller code. It's pretty dry. Maybe more interesting will be the last 5 minutes where I put the pieces together to get the scheduler and the microDot web services running. The results of this led me into some code optimizations that I'll show in the next video. One stage I was really worried I might have to rewrite this to run on a Raspberry Pi. So the last file interface I have for the NetLogger or netProbe is this NetLogger interface here. So the idea is, as the network probe is collecting data about Bing, ping, and web times and other information, it writes it out to files that I can later analyze by doing what will be a web service call to find out the history about, say, what's the round trip times to a certain host over a certain amount of time. So the way I set this NetLogger up, it's a class again. It has a file name of a logger by default if it finds there's the SD card, and we looked at that at the last video. If it has an SD card, then it prefixes the file name by /SD, so I'll go to the SD card. We have the file exists. Now, the first thing is to get the file name for this particular data we want to save to a NetLogger file. And the way I did this is fairly much the way I did it for the Garden Pico code as well, as have a separate file for each day, so I don't have one large file that I'm putting everything in. So each day as I'm logging data, it'll write to a certain file. Once that day finishes, it'll start a new file. And the other breakdowns is I have a separate file for each host ID and a separate file for each type of test. So we've got Bing, ping, and web tests. So if we're doing all three to a host, then we'll have 3 files out there each day for that host. And this is a little bit of code that builds up a unique file name that's based on all that information. So builds up a file that starts with ND, year, month, and day, and then the type. So that's where it's either a ping, Bing, or web file logger, and then the ID of the host. And you can see in here with the formatting, it goes in pads the zeros, so like for the ID, if it's ID1, it'll be file 001. And here's an example of kind of the output you get. Also, I append tab on the end as well, so that's a typical file name shown there. So let's look at the code for writing out a log record. So it receives a NetLogger record that is basically a Python object with properties that we want to log. So it's going to expect to find ID as one of the entries in the NetLogger record, and it'll raise an exception if it doesn't find it. So seeing my code is calling this, it should always have ID in it. It's going to expect to have a type in there and an indicator on whether the test, whether it's a Bing, ping, or web test, was successful or not, or failed miserably. Again, it's going to expect to see a success property in there with a true or false value. And it's also going to check for the type that it's either ping, Bing, or web as the type of record we're logging, because we log different details for each of those types of record. First we call logger line builder. So once we know that this NetLogger record has all the things we expect it to have in there, we built a logger line, and this is what code's doing, that build of the logger line. And you see in here, it's basically formatting a string that represents the line based on what it'd expect for a ping record, a Bing record, or a web record. So again, they have different number of tab delimited fields in that line, depending on whether it's what type of record it is. So once we've got that logger line, now we need to write it out to an appropriate file. So we're going to call our get nd file name. So this is where we could call that code up here that we just looked at for building a file name. And we need to pass to that the ID and the type that we're creating. Then it uses the current time to work out the rest of the file name. So it'll open up that file for appending as netDataLogger file, and then just write out that one line to that file, and we're done. So let's have a look at the results of this. So I've been running this logger code for the last few days. So here's an example of, let's have a look at pings. So I think this was on my garden network interface. So here we see it's showing the time, and this is a epoch time relative to 2000, because MicroPython uses epoch start date of year 2000 rather than 1970, and then all the round trip latency times it saw for that. So that's the ping format. If we're doing bings, we see in here we get 3 tab delimited values. So it's again the time that the test was done, the bandwidth that it saw, and the round trip latency. And then you see these sort of values in here. So Bing doesn't always work. There's a lot of conditions on whether a Bing was successful or not. So I think this -18 value. So if it has -1 in the bandwidth, it means the Bing was unsuccessful, and this value here tells us why is unsuccessful. And I think it's a lot of cases it's just the ping times are too random. They're not increasing with the size of the ping, so it really can't do a calculation, so it doesn't attempt to get a Bing result in that time, but it does record that it was unsuccessful. And let's look at a web example as well. So here's a web example. Again, we've got the timestamp of when the test was done, the round trip time in milliseconds for the web response, whether the match was true. So remember, for the web responses, we can match for look for a string in the web page results, and it'll come up true if it's matched. And then the HTTP status, 200 in case of those. Let's look at another example. Same sort of thing. We've got a lower response time from the web server. In this case, it's not matching the string that I had, so these are all coming up false. We're getting information come back, but hasn't got the string we expect in it. But it's still a 200 result. Last one. So same sort of thing. Again, how long the web took to respond. In this case, under a second, 708 milliseconds here. This time we are getting a match, so we must have found the string we expected in the web response. And again, it's a 200 status code. So let's just jump up to the main routine. We saw in the last video how I have the scheduler, and this is where the tests are run. So for example, if the test is a ping, if the result is none, which means the ping failed, then it writes out this information to the NetLogger. So here you see where ID is one of the properties of the object being passed to NetLogger. Ping is the type, and success is false. So it doesn't need to pass any other information to the NetLogger in this case. If it's successful, it passes the ID, the type is ping, and because it's successful, we have a round trip latency that gets passed to the NetLogger record, and success is true. Similar sort of thing for Bing, but it's different data being passed. So if it's successful, it's passing the bits per second and the round trip latency. And finally for the web, if it's successful, it's passing the milliseconds response time for the web, whether a match was found to the string, and the status, which we just saw. So the second part of the NetLogger functionality has been able to pull data from those net logs. So when I write the Angular UI for this, I'm going to do web requests to basically call this get history with, and this again is a lot like what I did in the Garden Pico. I'm going to pass a start time, so when in the history to start getting historic data, pass an ID and a type, and then what happens is this is going to run through, build an array of data that was collected about that particular host, and test type over the time range that was specified. The other thing that happens at the moment, I'm going to have a summary function, so I really don't want to send back all the data, all the detailed data for over a long period of time. There could be thousands of records if a ping is done every 5 minutes, and I'm asking for a month's worth of data. That could be really big and may not be something that MicroPython can even, or microDot can even support. So what I've set up at the moment is if over 12 hours of history is required, but less than 72 hours, then it summarizes by hour. And if it's more than 72 hours with a history requested, then it's going to summarize by D. And I'm going to change these values depending on what actually works. And if it's less than 12 hours, then it's not going to summarize at all. And I'm setting this flag here, summary type, to X, H, or D, depending on whether I'm summarizing at all, and then whether it's an hourly or daily summary. Once I've got all that worked out, then I do the same thing as I've done in the past. I start pulling the files that I'm interested in. So first I work out when I'm going to start getting the files for. So based on the start time that was passed, I work out what's epoch time for the start of that particular day, because I want to get the actual day, and the end time, which at the moment is just the current time. So this just by default will give you a range going from the start date up to the current time. And then I also have this range statement step by the number of seconds in a day. So basically it's going to loop for each day in this range. So it's going to get put together a log name. So again, I'm building up that log file name just the way I did it earlier, based on the current file date as we step through the days, and the type and the ID. I look to see whether that file exists out there. So if I started really early and hadn't got any log files yet, then it just skips this and tries again for the next day. If it does find a log file exists, then it opens up that log file for reading. It reads a line from that log file, or reads the lines from the log file. So basically puts all the lines in this logging file line, and then for each line in logging file line, so each test that was done that day for that particular type of test, it starts splitting the line by tabs, characters, because they're tab delimited files. So I have this line values which breaks up the line. It then starts reading the line. So remember, the first column in each line, or line value instance 0, is going to be the timestamp of when that test occurred in that file. And then I also pull the value, which is going to be the second column in those files. So it's either going to be round trip latency, bits per second for Bing, or it's going to be the response time from the web server, and that's always in the first column. And then depending on whether it's a summary operation I'm doing, if it's a summary operation I'm doing, I decide that by looking at whether I need to write out a summarized record based on things I've collected. So down here we're actually building up the summary information, but up here it's deciding, hey, do I have summary information and is it time to write it out? So if it's an hourly summary, then it's looking for this last summary time, or timestamp minus that last summary time. If it's more than seconds an hour, which is 3600, then it knows, hey, it's time to write out an hourly summary, that an hour's worth of data has been collected in the summarized data. Same thing for daily, but in this case it's seconds in the day. What happens as it's collecting the summary information, it's putting it into this array called values, each of the pieces of summary information. So first it sees whether we've got any data, which means the length of values will be greater than 0. If we have, then we use this calc statistics that's going to do some statistics work. So it'll run through all the values that we've got in the values array and calculate the mean, the number of items in that array. It's going to sort the values so that we can also do a percentile number. So percentile 50, which is the median, percentile of 10%, and percentile 90%. And that's useful for response times, especially because there can be a lot of variability over an hour, or especially over a day. So we want to sort of throw out the lowest and the highest values and just sort of see what's the typical range that 80% of the values are falling within, and what's the most what value occurs most often, which is kind of our 50th percentile range, but we also have the mean there. So this calc statistics bundles all that information up into an object and then returns that. So down here, after we've got that object, the entry object with all those values in it, the only other thing we need to do is add the timestamp to that entry. So the timestamp we want is the last summary time, so that's the start of the current hour or the start of the current day, and append it to our entry. So entry is the thing we're after. It's is going to have all the hourly and daily summaries. And then we just reset everything. So in this case, we just need to set our values array to an empty array again. We need to calculate when's the start of the next summary time. So basically whatever the current NetLogger record timestamp is, we want to either say that the start of the hour is whatever the start of the hour is for that time, or whatever is the start of the day. And that's going to drive us to once we've progressed through another hour, progressed through another day, to drop another summary record. After all that's done, this is kind of where we're building up the record. So all this is done first in case we've got information to summarize, and then we just keep maintaining our summary information, or if it's less than 12 hours in this case, just appends a detailed record. So detailed record just be the timestamp and the value. If it's not detailed record, if it's summarizing, then it just appends the value to our array of values. And then after all that, we break out, and because we've been building up summary records or summary data, if there's any values in our summary data table, then it needs to write out one more summary entry in our entries for that last entry. So that's the way it should work. So the way I tested this, if we go into main, I commented out a bunch of this, but down here I'm just exercising the NetLogger, getting a history for ping, and I think that should fall within summarizing by hour, and this one will summarize by day. So let's run that and see what happens. So this is what we got, and this is just printing out to give us an idea of what we've collected. So once we connect to the network, then it's showing the hour summary. So we're getting all these entries here. So we get an array of objects, and the objects have a timestamp. It has a value, which is going to be because we're summarizing by hour, that's going to be the mean, and then we have the 10th percentile, the 50th percentile, and the 90th percentile values. And I checked these values before, so this looks like it's doing the right thing. Most important thing is the 10th percentile is less than the 50th percentile, and the 50th percentile is less than the 90th percentile, and the 50th percentile should be fairly close around the mean as well. It shouldn't drift that far out. So that looks like it's working okay for the hourly. And then when I did our test of calling the same thing but for daily summaries, here we just got 2 entries returned, which is good because we only had 2 days worth of data in these logger files. So we had 3rd of June and the 2nd of June's data, and again it's got the percentiles, the value, which will be a mean for that day, and the timestamp for the beginning of the day. Same thing for the second day. So all that's working. Next thing I need to put in is I think I'm going to start on putting microDot in here, set that up as an asynchronous service, and try and get the scheduler here running as a synchronous service too. And that should be it for this video, so let's try doing that. Okay, I'm going to put all the bits together and basically use the same sort of structure as I had in Solar Garden. So basically when it starts up, it fires up this task which is called scheduler, which runs as an async task in the background. So once that's fired up, it'll run in the background, and then it'll run the actual microDot app. So that's the web server starts up there. And let's have a look at the scheduler. The same sort of thing as in the Solar Garden. So we have a loop that just stays on all the time. So I'll keep looping in here, goes through, and this scheduler things we had before does the pings, but we record out to the logger now for the pings, the bings, and the web. You'll notice in here I've also got a lot of information about the garbage collection memory free, because I was having trouble with that, which we'll see in a sec. So it all runs through, and then once it's processed one host, it'll say it's sleeping, and then doing a asyncio sleep for 20 seconds. So this gives the microDot a chance to look in. So let's try running that. And what you see here is it's giving me a memory error. It didn't have enough memory to allocate what it needed for the microDot async pi. And the reason for that is basically some of these libraries are using a lot of heap and leaving it fragmented. Makes it worse when I make this microDot asyncio the last import. So now if I go and save it, load this improved version to the device. Now we'll run it. So this time you see it's working. It's really just the way it allocated memory in the heap with that different order of imports, allows it to have enough memory to do what it needs for the actual running of the application. And there's my memory free information, so as garbage collects hits it, I think the memory freeze more normally stays around 52 kilobits. So there's our sync server starting up. And this shows you another problem here, is that while it's doing bings in the main scheduler, it doesn't give the web microDot a chance to get in and do its processing. But we see it here with the history request. It came back, but that can be up to 26 seconds based on the timing of the bing. So that's something I need to fix up as well. So next video, I'll have a look at things I can do to improve the memory usage for these large modules, and also not have it lock the microDot web server out while it's doing these large bings. There's things I think I can do for that, so I'll leave that for the next video.